Welcome to this educational module. The title of this is Structural Foundation Basics, and this is intended for basically public audience view to understand what issues they have with residential construction. I'm going to talk a little bit about the basics dealing with single-family residences and multifamily residences, primarily constructed out of wood frame. I'm a structural engineer. My name's Dilip Khatri. I've been a practicing structural engineer for 30 years, and I have my own practice in Pasadena, California. I've done a lot of work on residential and multifamily home reconstruction, dealing with foundation problems, and I always find that my clients need to have a basic understanding of what is involved in constructing their buildings so that they can understand how they can be repaired. So let's talk a little bit about the basics of wood frame construction to start off with, just to give you a little bit of background. And I'm going to go ahead and label these notes so that if you want to download them, you're welcome to. So the title of this module, Structural Foundation Basics, sheet number 1. And let's understand, there are two types of foundations that are used for building design in the residential and multifamily context. This was done essentially before 1970s, pre-1970s, 1960s. The majority of our buildings were constructed as follows. We had what's called a raised floor foundation system. And a raised floor foundation system consists of a footing, which is normally, say, 2 feet deep, with a base which is approximately 2 feet. A part of the footing here which is about 8 inches thick, very minimal amount of steel. On the bottom, there's what we call a mud sill. And then you have your building constructed on top of that, and then there's a floor joist system. This area in here is called the crawl space. And although I didn't draw it to scale here, that is usually a minimum of 18 inches. It's a little bit larger than the way I drew it. And then this is your wall system. This system, which is a raised floor foundation system, this system has pretty much been discontinued after 1975. You don't really see, probably even at the end of the 1960s, you don't see buildings really built like this anymore. And one of the reasons is that the cost of forming your foundation system and then putting your building up on top of it became rather cost prohibitive back in the 60s. And so the industry went in a new direction. They went in a new direction, and so the newer buildings are constructed using a slab on grade system. Sheet number 2. Slab on grade system was done primarily for economics. That system looks like this. That consists of a perimeter footing with a slab, and you usually have some crushed aggregate here with a visqueen membrane. I'll use some different colors here. You'll have some steel in here. You're supposed to have steel in the slab, although that's not always been done. And then you have your framing elements for your wall and your dirt line. And so this is a slab on grade foundation. And this is pretty much the way the buildings are built today. Probably 95, maybe 99% of them. I haven't seen any ones being built with a raised floor foundation. Now, why is that such an important thing to know? Because slab on grade systems have traditionally had lots of problems associated with them as follows. One of the biggest problems you have with slab on grade is I'll try to enumerate some of the issues that I've seen is that when we put the slab directly on the grade, one of the big problems we have, first of all, is moisture. Moisture and water with upward pressure. What happens is the slab-on system is subjected to upward earth pressure. If you're on expansive soil, it'll cause this slab to bend and crack. And what happens is, because in many cases they have not put the rebar in that they were supposed to, or it's inadequately placed, you'll have water seeping up through your slab. This has happened on thousands of homes. I've done so many inspections in this category. And what usually involves there is you have to come in here and fix these cracks. It causes all kinds of leveling issues. This kind of problem, very difficult to happen in a crawl space zone because you have this gap. And so slab-on grades are very susceptible to that problem. You have upward moisture, you have structural deflection occurring from expansive soil. Very common problem. And then you have soil settlement, which can occur for a multitude of reasons. And because with a slab-on grade system being so sensitive to any type of vertical movement, and let's draw a quick sketch of that to explain what I mean. If we look at a slab-on grade system in a typical building, you may have an interior footing in here, and let's say you have your building constructed here, and we'll just throw some dimensions on here. Let's say that this is 20 feet, this is 20 feet. A modest amount of movement at one of these points will cause that slab to crack. And of course, if you have upward pressure, soil expansiveness, it'll cause the slab to go into some sort of curvature mode, which will cause it to crack. You have the same thing can happen with a raised floor system, but a raised floor system, because the joists are separated from the dirt line, you don't have the same issues with moisture coming up through the floor system. You may have a problem with the floor settling, and we've seen lots of those. I've examined hundreds of buildings which have that problem. But the scope of the repair then focuses only on the perimeter footing, as opposed to a slab on grade, where you not only have an issue with the perimeter footing, but you also have issue with the interior slab. So soil settlement, structural deflection due to expansive soil, moisture and water going upward, very, very common problems. Another thing that comes up with slab on grade systems is what we call temperature shrinkage cracks. And so what happens there is the slab will exhibit some normal cracking, but if it does not have the adequate steel, if the steel is not there, this could become quite excessive. And I've actually seen situations where the slab is actually cracked all the way through and separated into separate pieces, and then that becomes a very expensive repair. These are very common problems that occur all over the United States, but in Southern California, we tend to see a lot of these. Let's talk a little bit about the grading operation on how these buildings are built, because that is a source of many problems. So you're going to construct a new building, and first thing you have to do is you have to create, I'm going to draw some line here, which is, we'll call this the existing grade. The first thing you have to do is you have to create a level pad. In creating that level pad, what's required before you can put your building up is you have to create a pad which is certified. That certified pad usually requires some level of what we call over-excavation. It's called over-excavation and recompaction. What does that mean? It means that I take the dirt, I dig down approximately 3 feet. It varies from soil to soil. Over the area of the pad, let's say that that's 50 feet for talking purposes. I take all this dirt out, I excavate, and then I put it back, but I compact it. And what that means is I run over it with a roller compactor in order to compress it, just like patting it down, pounding it down. And when I compact it, it's going to shrink, so I have to have some extra dirt in order to fill up the gap. It's usually going to shrink by 10 to 15%. So when I take 3 feet of dirt out and I put 3 feet of dirt back, it's not going to be the same 3 feet. I'm going to be 2 foot 6 inches. I'm going to be short, so I have to have extra dirt. That over excavation and recompaction, we say to 90% of the density of the soil, gives us a firm ground to build our house. This is standard procedure in today's construction. This is to be done on every house before it's built, not just for every house, for any building. Before you put up a foundation, you have to do what we call site preparation. The interesting thing about this is that that was not always the case. Before 1970, we didn't have pad certification. So buildings that were built before 1970, we don't know if the pads are certified. Also, they don't comply with the grading ordinances. 1972 was a landmark date because we had a major earthquake in 1971. That was the Sylmar earthquake. That caused all kinds of code changes, which were incorporated. And so buildings that were built before 1970 may or may not have these type of strict requirements. That's why we're always looking at the date and the age of the structure. Now, after you've certified your pad, then you can go ahead and construct your building. That still doesn't mean that you're not going to have any problems, because there are all kinds of issues that deal with hillside construction, such as subsurface water flow and poor drainage. If you have water ponding around your building, it could cause that building to sink, because remember, we're usually only preparing the top, say, 3 to 5 feet for the site preparation. The actual preparation of the entire hillside is a separate topic, which I'd like to discuss a little bit more in the next module. But just to give you a little basics, if your building is constructed on a raised floor foundation, it has a different type of performance, a different type of behavior, as opposed to a slab on grade system. That'll conclude our first module. Thank you.